This is to demo the audio portion of our project. It is going to go through the audio filter as well as the software. What we have here is the PCB, which is running the power for the audio filter. It's got plus 5 volts, minus 5 volts, 3.3 for the microcontroller, as well as ground. The audio filter is running on the breadboard because I botched the audio filter on the PCB. So we're connecting through the breadboard. We've got a microphone that's going to do the input, and then we've also got a function generator. Right now what we have on the oscilloscope, the top line, channel 1 is the input at the beginning of the audio filter coming directly off of the mic. Channel 2 is the output from the audio filter. So right now it's on the microphone. You can see that there's a lot of noise here. So that's getting amplified here. But if we play some sort of music, you can see that the microphone is reacting to that. If you see the green line, you can see the spikes. Alright. For the rest of this demo, I'm going to switch off the mic and just switch to the function generator so that we can better control the input. So what we're putting in right now is a 4 millivolt peak-to-peak signal from the function generator. Here it looks like it's almost 20 peak-to-peak. The output is, the divisions here are 20 millivolt on channel 1 and 2 volt on channel 2. So you can see that the peak-to-peak on channel 2 is about 4 volts. So it's about 200 times amplification on a signal that is 1 kilohertz. If we change the I'm going to change the frequency. I'm going to sweep through the speech range. We're up to 5. And our goal was that at 20, sorry, it looks like is it refreshing? At 20 it would reduce the amplification to about 20% of the amplification that it attenuates. Sorry, the amplification at 20 kilohertz would be about 20% of the amplification at the range with from about 1 to 3 kilohertz. So I'm going to bring that back down to 1 kilohertz. So we've got our sinusoid there again. I'm going to show here on the software. What we have here is a conversation flag that is a Boolean showing 1, showing that conversation is active. If I turn off the input, the Boolean stays active for several cycles before disabling. This is to indicate that there is some sort of pause or delay in conversation. If I turn it on, turn it back off, give it a cycle or two, turn it back on, you see that the timer resets to 0. When the timer runs out, it just sets itself to an arbitrarily large number. And so that, I believe, covers everything from the filter through to the software for the audio component of our project. Thank you.